Hello everyone, I am Annapurna SK from GMU A section. We are today explaining about the topic house price prediction from machine learning subject. So here goes the introduction. House price prediction plays a vital role in the real estate industry. It helps buyers, sellers, and policymakers make informed, data-driven decisions. In this project, we aim to develop and compare two regression models that we can accurately predict house prices. So next slide is about the importance of the project. Here, real estate is one of the most dynamic sectors with house prices influenced by multiple factors like income, location, and house characteristics. Accurate prediction helps buyers plan and budget effectively, sellers set the right price for their properties, real estate analysts and urban planners make better decisions and forecasts. So why do we use the housing data set? So the data set is based on 1990 US Census data and includes information from various housing blocks groups across California. It is clean, reliable, and widely used for benchmarking regression models. It includes a range of useful features like incoming levels, housing characteristics, population, and geographic data. It's easily accessible and preloaded in the scikit-learn library, making it convenient for machine learning projects. So the next slide is about the dataset description. The features used here are medlink, that is median income of households in the block. House age, it is median age of houses in the area. Av rooms is average number of rooms per household. Next is av bedrooms, that is average number of bedrooms per household. Population is total population of the block. Av occup is average number of people per household. Latitude and longitude is geographic coordinates of the block. The target variable here is about med house val, that is median house value for households in the block. This is what we are trying to predict. The further details will be given by my teammates. Thank you.
Hello everyone, I am Kaustava and today I will be presenting a project where we predict how house pricing using the two popular machine learning models, linear regression and decision tree regressor. Here's our workflow. We start by loading and explaining the datasets to understand the features. Then we normalize and split the data into training and training sets. Next, we train two regression models, linear regression and decision tree regressor. After training, we use the models to predict house prices. Finally, we evaluate the model performance using metrics like mean squared error and mean absolute error. Moving on to the next slide, that is linear linear regression and how it works. Linear regression is one of the most basic and widely used algorithm in supervised learning. It assumes a linear relationship between the features and the target variables. Calculate weight for each features and draw a straight line that best fits the data. In our cases, we estimate how features like income or number of rooms influence house price. But there is a catch. It doesn't handle non-linear or complex relationship very well. Moving on to the third slide, that is a decision tree regressor and how it works. Now let's talk about the decision tree regressor. Unlike linear models, this one splits the data based on conditions like income greater than 4. Each branch represents a rule and leaf node holds a prediction. And it captures nonlinear patterns and locations based effects. For example, how prices vary with latitude and longitude. The biggest advantage is that it can model complex data patterns better than linear regressions. And that's it for my part. Thank you.
Hello everyone, I am Chandana. Today I am here to explain about the model implementation, tools and process. Here we are using Python for data handling, model training and evaluation. Scikit-learn for accessing the data set, pre-processing of data and ML models. And here we are using Panda and NumPy for our data manipulation. Next, move to the code. First, there are importing the some of the Python libraries, that is Panda as PD, NumPy as NP, Matplotlib as PLT, Skyline dataset. Here we are using California housing prediction. So we are importing that particular housing prediction data from Skyline dataset. And Skyline model selection, we are importing the train and test split data models, and also linear regression, decision tree regressor, and for evaluation metrics, mean square error and mean absolute error we are importing. Then Panda and NumPy for data handling and numerical operations, and Matplotlib for plotting the graph, and Fetch California housing, that is loads the California housing data set, train and split, that splits the data into training and testing, and these are all the linear regression and decision tree are the two models we are comparing, and other two, that is mean absolute error and mean squared error, are the performance evaluation. Then housing is equal to fetch California housing and X and Y variables. Here in this housing, that fetches a data set, and X is the feature matrix, that is as average rooms, average bedrooms, that kind of matrix, and Y is the target values, that is median house prices. Then in X-train, X-test, Y-train, Y-test, this is where we are importing a train test split function to train and test the data. This splits the data into 80% training and 20% testing. Random state is equal to 42, that ensures the reproducibility. Then that is linear regression model LR, we are defining a function into a target variable, and that will fit the training data. Then that creates a training data for linear regression model. Then for decision tree also, we are giving a target variable by mentioning a decision regressor function. Here max depth 5, that prevents the overfitting. Then we are predicting the test values, predicting the house prices on a test data using both the models. Then we are calculating the mean square error and mean absolute error for both the models. That is the mean squared error penalizes the larger errors more, and mean absolute error gives the average error. Then this particular print statement will print the values, that is performance metrics, to compare the model accuracy. Then that is PLT dot figure. This will print the plots, that is actual versus predicted prices. That in that red dash lines, that means perfect prediction. That helps to visualize how close predictions are to the reality. Then that is importance, that is DT model dot feature importance. This will show the features of decision tree that which are found in a most important way. Then the higher importance means bigger influencer on a prediction. As overall summary of this particular code is that loads the data and splits it, trains the linear regression and decision models, compare them using mean square error and mean absolute error, visualizes the prediction and feature importance, helps to determine which model is more accurate and interpretability. Then let's move to this particular code output. As we know that it will give 4 graphs and evaluation metrics. First, we will get a, that is feature correlation heat map. This will helps to find the relationship between the data. As we can see on particular section, that is medlink house age, these are all the particular data frames in that particular data sets. Then comes a linear regression prediction and decision tree prediction graph, that is scatter graph. Here this is the graph between predicted price and actual price. And in decision tree prediction, here also prediction price versus actual price. This particular graph will give a evaluation metrics for comparing these two predictions of data. Then we will get a residual analysis. This residual analysis will give which has higher performance than which, using count and price metrics. Then we have a feature importance from decision tree. In this, which particular feature has more effect on a decision tree. As we know that medding, as according to this particular, we are finding the values for comparing both. These are all the features of that particular data, and this is the importance. As we know that medding has high importance, then as we will see here, that is first we will get a data set overview. It will give an overview of whole data set from Skyline. Then we will get a summary statistics. That means that is count, mean, standard deviation, minimum. That is minimum that is 20%, 50%, 75%, and max. These are all the features of a data set. That is, as we know, in a book column, that is house age, average rooms, average bedrooms. These are all the features of a data set, and this is the summary statistics of each data features. Then as we can see, that is panda code data frame. This is a data frame, and there is a range index, that is 20,640 entries are there, that is 0 to 20,639. Then data columns, total of 9 columns are there, which are printed here. That is medding, house age, average rooms, average bedrooms, population, average occupation, latitude, longitude, and price. As we can see that the data types are the float, that is 64-bit, that is of 9 columns are there. Then total usage of memory of this particular data set is 1.4 MB. Then model evaluation criteria. As we can see here, linear regression mean square error is 0.5559, and absolute error is 0.5332, and R2 score is 0.5758. Here we got an accuracy of average of 67% and precision of 70% 0.65, and F1 score of 67.78. And here for decision tree, we need to compare this to which has higher accuracy, that model will perform well. In decision tree, we do have a MAC, that is 0.5245, MAE as 5223, and R2 square as 0.5997. Accuracy we got here is 0.6516. Comparative with this, linear regression has higher accuracy, and precision also, linear regression has high precision than decision tree, and F1 score also. So by this we can conclude that the decision tree performs better due to lower MSI and greater R2 score. So that by evaluating this, decision tree performs well in this. Further will be continued by my teammate, which she will explain our further evaluation matrices. Thank you.
Matrix mean square error. One measures the average of the squares of errors between predicts and actual values. Next point, MEA, man absolute error, measures the average of the absolute difference between predict and actual values. Next point, R2 score indicates how well the model explains the variability of the response data. Next point, accuracy, precision, and F1 score. Accuracy, overall correctness. Precision, correct positive reduction out of the total positives. And recall. Next slide. Result, result comparison table. The decision tree register outperforms, outperforms linear regression across most metrics, indicating better handling of complex data. Next slide. Project outcomes. First one, comparison of different models, understanding models suitability of the problem. Next point, guidance skills in future importance. Experience with the data processing, model timing and optimization, developed data visualization skills, applied ML practices in a real world scenarios. Next slide, conclusion. Best performance, decision tree regression. Point, better for non-linear complex data. Next point, more flexibility in capturing patterns in incoming and location-based features. Linear regression is still valuable for quick and interpretable result. Thank you.